Welcome. Today's video is on titration calculations. So here's my version of titration. So don't laugh at my drawings. They're pretty good. So when we titrated in class, we had two burettes. One contained an acid and one contained a base. And the first thing we did was add some acid to an Erlenmeyer flask. So that's my drawing over here. And you read the before and the after volume, and the difference would tell you how much acid you added. Then we took that flask and moved it under the base burette, and we added the base slowly, one drop at a time, especially at the end, until it went from a clear solution to a pink solution. And that told us the endpoint for the acid-base titration. And what happens at the endpoint? Well, in our lab, we used hydrochloric acid and sodium hydroxide. And when they mix, an acid and base makes salt and water. And when is the endpoint? Well, that's when we had equal amounts of acid and base. So another way to write that is when the moles of the acid were equal to the moles of the base. And specifically, not of the acid itself, but the H plus part of the acid, and not of the base itself, but the OH minus of the base. When those two are equal, H plus and OH minus give water. And so when you have equal amounts, then it is neutral, because you have just one H plus for every one OH minus. Now, the formulas we used here all had just one. So this was one H to the HCl. This has one OH to every sodium hydroxide, but sometimes that is not the case. And we'll talk about that in a minute. So how would I calculate the moles of H plus and the moles of OH minus? Well, if you remember back to the quantification unit, we could use grams to solve for moles, but nowhere did we weigh anything, so we can't use the grams. What else do we know? Well, you knew the molarity of the acid. So you knew the moles per liter of the acid. In this case, it was moles of HCl. So if I want to find the moles when I know the molarity, I would just have to multiply this by the liters or the volume, okay, in liters. And that will give me the moles of HCl. But I don't want the moles of HCl. I want the moles of the H plus. So I have to look at the formula and see that there's 1 mole of H plus for every HCl. So I have 1 mole of H plus for every 1 mole of HCl. And so now moles of HCl cancel, liters cancel, and I just have moles of H plus on this side. Now I told you this example had 1 H for every HCl, but if you had an acid like H2SO4, you would have 2 moles for every 1 mole of acid. Or if you had H3PO4, phosphoric acid, you would have 3 moles of H plus for every 1 mole of H3PO4. So you have to look at the type of acid you're using. What about our base? Well, our base, we have 1 mole of hydroxide for every 1 mole of sodium hydroxide. Here we have 1 for 1 times the molarity of the base, so the moles of sodium hydroxide per liter times the volume in liters will give me moles of hydroxide. And once again, this first category is only 1 if it has a formula where it only has 1 OH in the base. All right? So let's turn that into a generic formula so I can use it for whatever acid or whatever base I'm using. So what did I do? I took the number of hydrogens in the formula. So HCl had 1 mole of hydrogens for HCl. H2SO4 would have 2. And H3PO4 would have 3. So the number of hydrogen ions available to react times the molarity of the acid times the volume of the acid will give me moles of H+. That is equal to the moles of hydroxide when it is neutral, when you reach the end point of your titration. And so on this side we have the number of hydroxides in the chemical formula. So if you have something like sodium hydroxide, you just have 1, but if you had something like calcium hydroxide, you would have 2. Times the molarity of the base, times the volume of the base. When these are equal, then you're at the end point of your titration. So here I have a generic equation, so write this down somewhere. And it's a generic equation with 1, 2, 3, 4, 5, 6 variables. As long as you know 5 of those variables, you can solve for the remaining 1. So I could solve for any of these 6, molarity of the acid, volume of the acid, number of hydroxide, ions, any of these 6 as long as I have the other 5. Well, what 5 did we know from our titration lab? Okay, well, let's give an example which is similar but not exactly to our titration lab. So what if you had the problem, what is the concentration of HCl acid if you obtain the following data from a titration and the base that you used is 0.15 molar sodium hydroxide? So here I have my generic equation. Here I have my data. So number of hydrogen ions. So I look at the formula, which is HCl. So there's 1 H plus in the HCl formula, times the volume of the acid. Well, how do I get the volume of the acid? I have to do an easy subtraction here. This is the, notice I put the after above the before. The after minus the before gives me 2.3211 milliliters. And here I have the base, which we'll calculate in a minute. So times 2.3211 milliliters. Now you might say, but Miss Backus, you said we needed liters. Well, you can go ahead and convert this to liters, but this equation also works as long as I use the same units on both sides. So it works if these are liters on this side and liters on the other side, but it also works if there's milliliters on both sides. And you can prove that to yourself by multiplying each side by 1 over 1,000, and notice that it would cancel out. So if you convert both of them to liters, it would cancel. Times the molarity of the acid. That's my unknown. So Ma equals the number of hydroxides. Well, here's my base. So I just have 1 OH in that formula. The volume of the base, I subtract these and get 3.2131 milliliters times 3.2131 milliliters times the molarity of the base, that's given to me 0.15 molar. So now I just have to rearrange this equation and solve for the molarity of the acid, which happens to equal 0.2076, but I can only have 2 sig fig, so 0.21 molar. There you have it, solving problems for titration. So what do you need? You need your data from the titration, and you need this generic formula. Then you plug it in and solve for the missing variable. Thanks for listening. Hope you do well.